Welcome to clickmyproject.com. Now we're going to see about JS Reduce defending our data from sequential background knowledge attacks is under the domain of data mining. What is data mining? Data mining consists of number of techniques were manufactured automatically and interestingly to retrieve the information from the large amount of database which consists of sensitive information also. It requires data preparation which can uncover information which may compromise confidentiality and privacy obligations. Now I'm going to explain the abstract of the paper. In this paper, to show the correlation among sensitive values associated to the same individual in different releases can be easily used to violate users' privacy by adversaries. They observe multiple data releases, even if state-of-the-art privacy protection techniques are applied here. Now I'm going to explain the brief concept of the paper. Large amount of data related to individuals are continuously acquired and stored by corporate and government institutions. Some examples include mobile survey requests, web queries, credit card transaction, and transit database records. These institutions often need to repeatedly release new or update a portion of the data to other partner institutions for different purposes, including distributed processing, participation in inter-organization workflows, and data analysis. So the new records are periodically released to data analysis centers in non-aggregated form. A challenging issue in this scenario is the protection of users' privacy, considering that potential adversaries have access to multiple serial releases and can easily acquire background knowledge related to the specific domain. This knowledge includes the fact that certain sequence of values in subsequent releases are more likely to be observed than other sequences. So to prevent individual information is to use the JS algorithm. Our proposed defense algorithm is based on JS divergence. JS divergence used as a measure of similarity. JS reduced to enforces the K anonymity and T closeness in order to protect against well-known identity and attribute disclosure attacks respectively. Our defense provides strong privacy protection and good data utility even when the adversary has more accurate background knowledge than the defender. In existing privacy protection approaches can be divided in microdata anonymity and differential privacy methods. How will use microdata anonymity? Microdata anonymity works are focused on techniques dealing either with multiple data releases or with adversary background knowledge, but limited to a single data release. So this technique cannot be applied to proposed. What is the use of differential privacy method? Differential privacy method provides a rigorous and quantified notion of privacy, and it can be applied to several data mining and machine learning tasks. This technique cannot be applied to proposed system because in this technique only consider the static data set. Either a tuple is added or removed from the dataset and tuples values do not change with time. So this technique cannot be applied to proposed system. In our proposed system, there are two types of probabilities considered here. First one is transient, second one is persistent. Transient values that may freely change with time, and persistent values that never change. Our privacy preserving technique captures non-uniform transition probabilities. Now I'm going to explain them. Our proposed algorithm. Our proposed algorithm name is JS Reduce. The goal of JS Reduce is to create quasi-identified groups whose tuples respondents have similar revised sensitive background knowledge distributions. If the respondents of tuples in a quasi-identified groups are indistinguishable with respect to revised sensitive background knowledge, the adversary cannot exploit background knowledge to perform the attack. The defending against background knowledge attacks is not sufficient to guarantee privacy protection against other kinds of attacks. For this reason, JS Reduce also enforces K anonymity and L diversity in order to protect against well-known identity and attribute disclosure attacks. JS Reduce can be easily extended to enforce additional privacy models like L diversity. JS divergence is a measure of the distance between two probability distributions, which can also be generalized to measure the distance between the finite number of distributions. Inside JS divergence, there are two types of methods to be applied here: K anonymity and T closeness. K anonymity, which prevents identification of individual records in the data. T closeness, which requires that the distribution of the sensitive attributes in any equivalence class is close to the distribution of the attribute in the overall table. That means the distance between the two distributions should be no more than the threshold value T. Finally, this algorithm is to provide a strong protection of data units. In future, to add L diversity model in JS Reduce algorithm. I'm going to explain system architecture of the paper. First, the data is loaded into the project. For example, to consider a medical data set, the name of the attributes are patient name, age, gender, and zip code, and then medical test results. Then, next, to compute the value of BKSV and BKSEQ. What is BKSV? BKSV is nothing but sensitive values background knowledge. It represents the a priori probability of associating an individual to a sensitive value. What is BKSEQ? Is nothing but sequential background knowledge. It's a function that returns the probability distribution of sensitive at time tj. Next to extracting knowledge of PKSV and RBKSV. What is PKSV? PKSV nothing but sensitive posterior knowledge is computed according at timeline at T1 and T2. What is RBKSV? Is nothing but revised sensitive knowledge is computed the probability of posterior values. Next, these values are applied to JS reduce algorithm. Inside the JS reduce algorithm, there are two types of methods to be applied here: T closure and K anonymity. Both are to protect against well-known identity and attribute disclosure attacks. Finally, the data to be published. I'm going to explain demo for project. First, start WAMP server because database are loaded from MySQL. Next, to open admins to execute load.java form. Click loading. Successfully loaded message box is displayed, and click at T1. Time T1 datasets are displayed into the tables, and click at time T2. Time T2 database are displayed here, and click compute. The next new form is open. Click BKSV button. The background sensitive knowledge is computed, which means each sensitive attribute properties are computed, and click BK sequence. The background sequential knowledges are computed, which means the past observation of sensitive probabilities are evaluated. We simply said the button BKSV is to do the calculation of T1 data probabilities, and BKSU button to do the calculation of T2 data probabilities, and click extract. The next new form is open. To click at T1, posterior sensitive knowledge is computed. Here to consider quasi identifier group. In this table, the quasi identifier groups are result column attributes. To compose these quasi identifier, for example, MAM pos is this value is presented in 3 times. So these 3 values are composed and probability value is computed. And click at team 2. Similarly, the composed quasi identifier probability value is computed at T2, and click revised. The next new form is open. Click RBKSV. Revised background sensitive knowledge is computed. Here, to compute the probability of individual respondent, whether the same individual respondent is presented, this probability value is combined. And click JS reduce. The next new form is open here. Click RBKSV button. Here all revised background sensitive knowledge probability values are submitted into the table, and click threshold. Here the T closeness method is to submit one threshold value, that is 0.25. This threshold value is compared to all RBK values. If it is these values are greater than equal to threshold value, so automatically modified threshold value is less than or equal to 0.25. And click K anonymity. The next new form is open. Click K anonymity. The message box is displayed here, and click display. Here the age and zip attribute values are modified. Like the age between 40 to 60, and zip code start with 120 190. These results are released in institutions. So click publish. The result is sold, and click LDVT. Click LDVT button. Here the probability value is computed, because Click L diversity. Here the association between three tuple probability values are computed. These values are greater than threshold value. So to hide one more attribute, gender. This is the final result to release to the public institutions. Finally, I conclude this project to hiding and modifying one or two attributes. So what is the purpose to hiding this attribute? Means adversary cannot get the background knowledge. Thank you for listening.